Seasons. What do you imagine when you read these words? Summer, spring, fall, winter? Most of us come up with a mental picture or two. Summer means shorts and t-shirts, swimming in fresh fruits and vegetables. Winter means heavy coats and short days, perhaps with a blanket of snow on everything. Seasons are pretty easy to tell apart in most of the United States. The amount of daylight, the average temperature, and the behavior of plants and animals are a few familiar indications of season. But what causes the predictable change of season? What have you learned in class that helps you explain the reasons for seasons? As Earth tilts. Let's start with a quick review of some basic information about Earth. Earth spins on an imaginary axle called an axis. The axis passes through the north and south poles. The spinning on the axis is called rotation. It takes 24 hours for Earth to make one complete rotation. Earth travels around, or orbits, the Sun, traveling around something that is called a revolution. One revolution takes 365 and 1/4 days, which we call 1 year. Earth isn't straight up and down on its axis. As it revolves around the Sun, it is tilted at a 23.5-degree angle. The average distance between the Sun and Earth is about 150 million kilometers. Earth's orbit is slightly oval, so Earth is sometimes further away and sometimes closer to the Sun. The distance is so insignificant, that means it doesn't really matter, that it is not related to the seasons. It would seem logical that summer would be when Earth is closest to the Sun. That idea is wrong. Each year when Earth is closest to the Sun, the northern hemisphere experiences winter. The reasons for the seasons are linked to Earth's tilt, not the distance from the Sun. Think about Earth orbiting the Sun. As Earth orbits, it also rotates on its axis, one rotation every 24 hours. Here's something important. Earth's north pole points towards a reference star called the North Star. No matter where Earth is in its orbit around the Sun, the North Pole points towards the North Star, day and night, every day, all year. Look at the illustration on page 41. It shows where Earth is in its orbit around the Sun at each season. You will also see that the North Pole points towards the North Star in all 4 seasons. Study the Earth diagram in the summer solstice position. Because of the tilt, the North Pole is leaning towards the Sun. When the North Pole is leaning towards the Sun, daylight is longer, and the angle at which the light hits part of the Earth is more direct. Both of these factors result in more solar energy falling on the northern hemisphere. It is the summer even though the Earth is actually further away from the Sun. Look at the position of Earth 6 months later. Now the opposite is true. Even though Earth is closer to the Sun at this time, the northern hemisphere is tilted away from the Sun. Daylight hours are shorter, and sunlight does not come as directly to the northern hemisphere, so it gets less solar energy. It is winter in the northern hemisphere. 4 days in the year have names based on Earth's location around the Sun. In the northern hemisphere, summer solstice is June 21st or 22nd, when the North Pole tilts towards the Sun. Winter solstice is December 21st or 22nd, when the North Pole tilts away from the Sun. The 2 days when the Sun's rays shine straight down on the equator are the equinoxes. On these 2 days, Earth's axis is tilted neither away from nor towards the Sun. Equinox means equal night. Daylight and darkness are equal, all over Earth. There are 2 equinoxes each year, the spring equinox in March and the fall equinox in September. We take day and night for granted. They always happen. Earth rotates on its axis and the Sun appears to rise. Then the Sun appears to set. This cycle is happening at least as long as humans have been on Earth. It will most likely continue for millions of years. Because Earth is tilted, the length of the day and night for any one place on Earth changes as the year passes. This table shows how hours of daylight change at different latitudes during the year. When it's summer in the northern hemisphere, the North Pole tilts towards the Sun. During this time at the North Pole, the Sun never sets above the Arctic Circle. Daylight can last up to 24 hours of the day in the summer. Darkness can last up to 24 hours of the day during the winter.